Hello. This is the first of the four videos that I am creating because I'm not there in the week of June 22 to 26. So, hello. Uh, if you're watching, comment. I'm not sure if it's comment. Probably not. Say hi, I guess. All right. The first lesson, piggybacking on what we did during last Thursday. Remember, because Friday was the graduation, is area between curves. Let's give an application on what the fundamental theorem of calculus was, right? Okay, changing videos. All right. So recall that the fundamental theorem of calculus states that if we want to find the definite integral from a to b of f of x dx, then we just find the integral of f, right? Then subtract the output of that integral b minus a. Okay, so it looks like this. Okay, so for example, the integral of x dx from negative 1 to 1, okay, is equal to the integral of x, which is, if we recall, x squared over 2, from negative 1 to 1, okay, which is equal to 1 squared over 2 minus negative 1 squared over 2, which is at the end equal to 0. Okay, all right. Now, would be nice if there was some way for us to like know what this really means. Okay. Now, the natural the natural application of this is what we call the area under the curve. So for example, if we have some function here, so this is the y-axis, this is the x-axis. Say we have a function that looks like this. So this is f of x, right? And moreover, if we have some a here and b here, then we want to find the area of this part here. Okay. This area right here under the curve f of x will be given by the integral of f of x dx from a to b. So this tells you the area under the function, but above the x-axis. As you notice, this is our x-axis, and the area on top is what we're considering. Between x equals a and x equals b. Okay. Now that makes sense. In the way that if you want to find this integral right here, the want to find this area right here, what we're actually doing is we're taking smaller and smaller slices of that area right here. Right? Now for each of those slices, for each of those slices, what we have is we can approximate it like a rectangle. Now, if we blow up that rectangle here, so for example, we have this rectangle here, this, let's call this the strip. Okay. Now, the height of this rectangle is exactly what the value of f of x is at that point. So for example, if we have here, if we have x here, the value of the length of the height, sorry, of the rectangle is will be given by where f of x is, right, on the graph. So the height is f of x, and right here, the slices, we call those the change in x. We how thin or thick the slices will be, right? So the width right here is dx. Now, what is the area of this rectangle? The area would be f of x dx, right? And if we have some finite number of strips, to find the total area under the curve, we add them all up using the sigma notation. But what we want is for our approximation to be as good as possible. So what do? Well, we make the strips thinner and thinner and thinner until dx right here becomes very, very, very small. And then the sigma notation here becomes an integral. Okay? So these are, so if we keep on slicing them apart, this is the approximation we get. And what we want is that this approximation to be as good as possible. We have as many slices as we can. Hence, from discrete, it becomes continuous. That is the meaning of the integral right here. Okay? All right. Let's have an example. Say we want to find the area under the curve y equals 2x above the x-axis from 0 to 2. Okay? Now, the way we can do this easily is, if we recall, what would be the graph of y equals 2x? Yeah? And we need to note from what x to what x. In this case, it's from x equals 0. You know what I should do? I should put something below. So it's from x equals 0 up to x equals 2. Let's say here. Okay? Now, so it's the graph of y equals 2x. So the graph of that will just be a line. So if x equals 0, what is y equal to? Well, y is equal to 0. Okay, so uh, I'll draw it using this. And if x equals 2, then y equals 4. So let's say somewhere here. All right. And I don't have a ruler. So that's what we get. Now, that means as well that what the area is this. this is the area that we want, right? Now, it kind of looks janky, but it's supposed to be a straight line here. I'm a dog show it. Okay. Now, we can solve the area in multiple ways. The most natural way is to realize that, for example, this is a right triangle with uh, legs that are, so solution one, so right triangle solution. So we have that uh, the length is 2, the height is, so the length is 2, and the height here is this one, 4, right? Height is 4, therefore 1/2 2 times 4 is 4 square units. Okay, but we know some integral calculus. So what can we do instead? Well, let's set up the integral. What we want is to find the area under this curve, which is, if we recall, y equals 2x, okay, from 0 to 2. In that case, let's use the concept that we have established and call that the integral that we want is the integral of 2x dx from x equals 0 to x equals 4. Sorry, x equals 2, rather. Okay, so from 0 to 2. This is not a hardship. The integral of 2x is just x squared. And we're evaluating it from 0 to 2, which is equal to 2 squared minus 0 squared. So that's 4 minus 0, 4. Yeah. Now for this particular example, it's quite easy because the figure that we're gonna get is just a right triangle. But in many other cases, the area that we're gonna get will not be as neat as this. Okay. And by the way, uh, for this particular example, try to write square units. Okay. Uh, don't forget the unit. Okay. In which case it's square units. However, if you forget it, this is one of those uh problems where I'm more lenient about the lack of units anyway. So, but it's best practice if you put it. Okay. Right. So far what we have established is an area between area under the curve. So page 1. This is example number 1. Now, what if we have two curves? Okay. In this particular example, suppose what we want to find is the area bounded by y equals 2x, but above y equals x. It's still from 0 to 2. Okay. All right. Now, drawing that is not such a hardship. Okay. I know I'm lying that you don't need graphing for this class. You kind of do. We're not gonna graph explicitly, but knowing the graphs of many things, simplifies your life a lot. Okay. Right. Okay. So if we graph that, so this is x, this is y. All right. So it's a graph from 0 to 2 pa rin. So from 0 to 2. Now let's graph these two curves right here. Y equals 2x. So in this case, it's from 0, 0 to 2, 4. So uh, it looks like this. Okay. Eh, Should I get a ruler? Nah. So it's that. Then, of course, we also have y equals x. So it's from 0, 0 still. But now it's up to 2, 2. Okay. So something that looks like this. Yeah. So what is now the area in question? Well, the area in question is now this right here. That is the area that we want. But if you look at it closely, how do we get this area right here? Right? Well, the easy way is if we take out this larger right triangle here, right? So we have this right triangle. Let me, for just for labeling sake, let me call it A, B, C, D. Okay. So this triangle here, bigger triangle, let's call this ABD. Right? And it has an area. So this is the area of ABD. Okay. Then how do we then get this area right here, this red area here? Simple answer. We draw ACD on top of ABD. So this is ACD. Okay. Then from the blue rectangle here, we then subtract the area of the blue rect. What do you mean rectangle? The triangles, yeah? So from ABD, we subtract the area of triangle ACD, right? So area of ABD minus area of ACD. This should give you the area of triangle ABC, right? Now, okay, let's do the let's do the integrals. So we have area of ABD of ABC, which is what we want, is equal to the area of ABD minus area of ACD. So this is what we want. Area of ABC. This is A. Okay. How do we set up the area of ABD? Okay. Remember that this function right here, this is y equals 2x. This function right here, this is y equals x. So to set up the area of ABD, the simple answer is this is the integral, okay, from 0 to 2 of what function? Of y equals 2x, of 2x dx, okay? An area of ACD, in this particular case, would be the area under y equals x, so x dx, between 0 and 2. Now, if we combine them, this would then be equal to the area from 0 to 2 of 2x minus x dx. Right? We can combine them. The reason being is they have the same bounds. Okay? But we can simplify this even further. This is equal to the area of 0 to x dx. Right? And of course, this is equal to 2 square units. Okay? So this item right here tells us that if we want to find the area bounded by two curves, you find the area bounded by the curve above minus, so this is the curve above, minus the area of the curve of the curve bounded below, right? As long as we know that one curve is above the other, okay? So this right here is the third concept and an important theorem. I'll write it in full. Theorem. If f and g are continuous, with f of x is greater than g of x over an interval AB, then the area bounded, there's only one, there's only two D's in bounded, what the hell? Bounded by f of x and g of x over the interval AB is given by the integral of f of x minus g of x dx from A to B. Okay. Now let's look at this line by line. If f and g are continuous, so if you remember back in 30.13 what continuity is, right? Like if you can draw a graph, if you can draw the graph without lifting your pen, all that jazz. Uh, I guess one thing that you need to take into consideration if there's a point in the interval AB where either f or g or both of them are discontinuous, then this theorem does not exist. For example, if f is 1 over x, of course the interval cannot contain 0. Things like that. So you might need to break it apart. Okay. With f of x is greater than g of x over an interval AB. What does this mean? This means that f is above g over the interval. Okay? So an example with this is if this is the interval AB, your two functions might look like this and this, right? In this particular case, the red function is obviously above uh the the black function here. Another example would have been if we have this, then if we have Right. Now, for this particular example, it is not the case where in the entire interval AB, one function is above the other. In fact, at this point right here, it changes. So let's call this point C. So in interval AC, the black is above the red, and from CB, the red is above the black. Okay? Which is important if you're given a certain function and uh you're asked to set up the integral. Okay? All right. Then the area bounded by f of x and g of x over the interval AB is given by the integral of f of x gx from a to b. Or, in other terms, interval over AB of the function on above, function above minus the function below. Okay? So, that's it. As long as we know which is the function above and which is the function below, we will be okay. Okay? Now, what are examples of problems for this thing? So, for this video, we're gonna do 4 problems. Then, of course, there's a quiz that you can take for this uh lesson. Okay, that you must take pala, sorry. This will be part of your points in the seat work. Okay, find the area between the graph of f of x equals x squared minus 9 and the x-axis over the interval 2, 4. Okay, now you might be wondering, sir, question, I do I'm scared of graphing. Uh, do I really need to know how to graph y equals x squared minus 9? The answer is no, but it's better if you do. What do I mean by that? So if you know your derivatives, sorry, if you know your quadratics, you know that the graph of this function, okay, the graph of this function will be like uh if x equals 0, then y equals -9, and that will be the vertex of the graph. And it's a parabola facing upwards that looks like this, right? Now, if x is equal, if the interval is 2, 4, what is the value of y in that interval? Now, what we do is you substitute 2 to here, you get uh f of 2 is equal to 4 minus 9, -5. So somewhere here, let's say 2. So I think I screwed up. Let's let's keep -5 there, but I'm gonna move to here. Then 4, where is 4? 4 squared minus 9, that's equal to what? That's equal to 16 minus 9, that's 7. So somewhere here, like that. So we have that. So what is now the area that we're looking for? Okay. What is now the area that we're looking for? the area that we're looking for is the area between the graph, between this graph right here, f of x, and the x-axis over the interval. So it's this and this, right? That's the area that we're looking for. Now, notice that one caveat here pala is that uh this is just the integral. This is this area right here. This is signed area, meaning it matters where the area is. If the area is above the x-axis, then it's positive, and if it's below the x-axis, that's negative. All right? Does it make sense? So, and that so in this particular case, do we need to take note of that? Well, let's try anyway. Let's try to just implement the theorem that we had. Yeah. Now, for this part right here, the function f is above the x-axis, right? So if we use this right here, then from this point to 4, the area will be f minus 0, okay? F of x minus 0 dx, right? Why is it minus 0? This is the function for the x-axis. Remember that the x-axis is y equals 0. Okay? Now, what are the bounds? What is this point right here? So it's the point where x squared minus 9 crosses the x-axis. And to solve for that, you just equate x squared minus 9 to 0. In that case, you're going to get that x is equal to 3. So from 3 to 4, f of x minus 0 dx, which is 3 to 4, x squared minus 9 minus 0 dx. Okay. Now, okay, that's not such a hardship. By the way, if you have this and this calculator right here, okay, the Casio, you have this, and you can input uh you can put input I forgot where the axis is. Uh x squared minus 9 from 3 to 4. You get this. If you input it right there. So this is equal to 10/3. Okay. And the second area that we're looking for is this area right here. Now, the one on top is 0. So this becomes 0 minus f of x. And the one below is f of x. So 0 and f of x is below. Okay. Now, this is from 2 to 3. 2 to 3. So 2 to 3 of 0 minus x squared minus 9. So this becomes 9 minus x squared dx, which is equal to what? By this reckoning, so how do you get the x pala? So shift, and you see an x here. right? That x. So that's how you get an x. The function is 9 minus x squared from 2 to 3. You're gonna get 8/3. And you and if you add them, because uh the final area is this plus this, right? Uh in which the total area would be 18/3, which is equal to 6. Okay, 10/3 plus 8/3. Okay. However, however, there are there will be cases where sometimes you're just given a graph. Okay. For example, you're given this graph. And what you will be given is this area right here and this area right here. Okay. For example, this is 4. The area of this curve right here is 4, and this area is also 4. Now, if the if the question asks what is the total signed area of this graph, okay, this would be positive 4 plus negative 4, because the other area right here is at below the x-axis. So for this particular example, okay, all right, yeah, uh, 6, okay. But again, uh, if it says what is the total signed area, where it matters what the sign is, you need to be careful of saying positive and negative. Okay. All right. The reason pala why we're uh doing the which function is above the other is so that we can apply this right here without ever uh without ever uh figuring out what uh if it's a signed area. Okay. As a challenge, as a challenge, okay, and this is number one of your uh quiz. What happens if you just solve for the integral of x squared minus 9 dx from 2 to 4? What is this number? Okay. When I ask what is this number, I'm not asking what the number is. I'm asking what is that number in relation to the lesson, right? Okay. So this is page 5. So we have our next number. Now, we want to find the area bounded by these graphs right here, by f of x equals 1 half x plus 3, g of x equals negative x squared plus 1, x equals negative 2, and x equals 1. Right? Now, you can graph this. Okay? You can definitely graph this, in which case, what do we get? The graph of 1 half x plus 3 is what I do for lines kang pala is I just substitute two values, and uh that will give me 2 points, and that's enough. 2 points make a line. Okay. So in that case, x equals 0 will give me uh y equals 3. So somewhere here, let's call this point A. Let's call this 3, then 0 is here. Okay. Then if x equals 2, right? If x equals 2, then for this particular case, you have x equals 2, y equals 4, right? So if x equals 2, y equals 4, so there, then the graph in question will just be those 2 points connected. Okay, okay, so this is f right here. What is the graph of the other function? Negative x squared plus 1. Well, if x equals 0, then y equals 1. Unlike linear functions pala, where you just need 2 points, in here, you kind of just need uh 3 points, right? You need uh you need the vertex, or where the parabola is originating from, and you need 2 points on either side so that you can connect those parabolas, right? Now in this particular example, what we have is the vertex would be uh right. There are many ways to get the vertex. uh the way that you know, that you subconsciously know, but you don't really realize that it's the vertex, is remember in 30.13 when you're asked to find the critical points, right? You find the derivative and you equate to 0. That is a vertex. That is the x coordinate of the vertex. Okay? Because if you remember, the vertex is where the minimum or maximum is. Because remember, a parabola either looks like this or looks like this. So the vertex is where the minimum or maximum occurs. So technically, the critical point that you're looking for in 30.13, that's it. That's the x coordinate vertex. And to get the y coordinate, you just substitute it, right? I think there's a formula, but to get that, it's the same thing. You equate the derivative to of the quadratic to 0, then you find the critical points. But in this case, I think the x, if I'm not mistaken, this is the x coordinate vertex. Yeah. Then of course you just substitute this to whatever. Okay. Now for this particular case, the vertex is just at x equals 0 and y equals 1. So somewhere here. Then we also notice that when x equals plus minus 1, right? When you solve for x when this is equated to 0, what we get is our 2 points on either side. Okay. And if we graph the parabola, it looks like this. Okay. Now, now, so x equals that. So this is okay. This is okay. X equals -2. So somewhere here, and it's just this right here, right? And x equals 1. So somewhere here. And so the final area that we're looking at is this. Okay. Right. Then of course from here it's very obvious what the uh function above is and what the function below is. Okay. Now, is there a way? Is there a way uh to do this computationally, right? Is there a way to do this computationally? The answer is yes. So this is graphical. Computationally, what you can do is try to uh solve for the inequality f of x is greater than or equal to g of x. Solve the inequality. All right. So if we solve the inequality right here, it would be 1 half x plus 3 is greater than or equal to negative x squared plus 1. 0 is greater than or equal to negative x squared uh, minus 1 half x minus 2. Right? And if we uh, simplify that even further, 0, if we multiply both sides by negative 2, right? So this flips, this inequality flips to this, and this becomes 2x squared minus x plus x plus 4. Okay. Now, if you notice, this right here, this right here is true for all x. Okay. Meaning, by the way, you can solve inequalities using this calculator. Go to mode. Can you? You can't. I stand corrected. You can solve using this, however. Mode, then inequality, b, right? Polynomial is 2. Uh, in which case we want to solve this inequality here. So we want less than or equal to 0. So we want number 3. And we input the coefficients 2, 1, 4. And it says all real numbers. Okay. So that means that for all x, so that means for all x, this is true. So meaning, for all x, the f is above, the g is below. For all x. So including from x equals -2 to 1. Okay? This means that we can then find this integral right here. This area right here. And of course, the way to find it is by just using the integral. So it's from negative 2 to 1 of the above function minus the below function. Above function, okay, the above function is this one, 1 half x plus 3, and the below function is this one. Notice that I am enclosing everything in parentheses. Okay? Don't just write this. 1 half x plus 3 minus negative x squared plus 1. Don't just write that. This is bad math. Okay? And of course, dx. Right? Now, we can calculate that. Right? So the integral of 1 half x plus 3 plus x squared minus 1 from negative 2 to 1. The final answer is 33 over 4. Sir, question. Uh, is that okay? Like, can we just directly write the answer? Okay. Uh, Look. The reason why I'm doing this directly is because of space. Ideally, sana you should uh do this, then uh find the integral, right? This right here, this is just uh this is just for approval or for like verification. Okay, so don't take shortcuts. But in the case that you don't have any time, you just do this, then you write it directly. I'm not uh I'm gonna be lenient naman. But again, try to write the entire thing. Okay, so this is page 6. Okay, second to the last. Find the area bounded by f of x equals 5 minus x squared and g of x equals 2 minus 2x. Now, you could graph this for sure. We could do the same thing as we did before, but let's just do this computationally. Okay? So, in computationally, we want to find which is the above function, which is the below function. In this particular case, let's try to solve f of x is greater than or equal to g of x. Okay? So in this case, 5 minus x squared is greater than or equal to 2 minus 2x, right? So 3 plus 2x minus x squared is greater than or equal to 0, right? And uh, x squared minus 2x minus 3 is less than or equal to 0, right? X minus 3 times x plus 1 is is less than or equal to 0. Now, if you have this already, again, the reason why this flipped is we multiplied by negative 1. Okay? Then after multiplying by negative 1, it flips. We factor it out. Then this means that the numbers that we need are x equals 3 and x equals negative 1, right? So here's a shortcut, especially for just quadratica. So you put this in the number line, okay? So x equals -1, x equals 3. That means that you have three intervals. You have everything less than -1, you have everything greater than 3, and you have everything in between -1 and 3. So what do we want? If it's less than or equal to, it's in between. If it's greater than or equal to, it's everything to the side. Okay? So this means that since that this is less than or equal to, this is the integral that we want. So it's everything from -1 to 3. So this is where the function f is above g. Okay? Now, how then do we use this? Well, I was guessing that you don't need graphing, but because you kind of need to know, for example, if we have, where does this integral, where does this lie? Where does, no, sorry. What, this faces downwards, right? Because it's -x squared. So the parabola looks like that. And there's a line cutting that parabola. Bam. Okay. So that means that this is the area that we want. All right. Then whatever this is, that's uh those are the points that we want. So in this case, the parabola f is above the line g, right? And this would be the area bounded by the parabola and the line. This is what the graph will look like. Okay? So to set up the integral, so let's call this the area, it would be the parabola, which is 5 minus x squared, minus g of x, which is the line, dx from, from -1 to 3. That is what we want. Okay? It's from -1 to 3. It can also be the case that the parabola faces upward and we have a line here. And this would be the area bounded by the parabola. Okay? Then of course, you can solve that directly. But I'ma use the calculator because I am happy to do so. 5 minus uh x squared minus 2 plus 2x from -1 to 3, we get 32 over 3. Very nice. Leave it as fractions. Don't worry about making it decimals. Just leave it as fractions. Okay? Unless the given is decimals. Right. So for this particular types of questions, you have two cases. You have either this or this. But yeah, you have two cases. It's either this or this. Okay. All right. Last item. This is from, I think, midterms 2 years ago. So midterms SY 23-24. Okay. Set up the integrals that will give the area of A. So uh So you have three functions here. You have f of x here, this one. So that's f of x. You have g of x here, that looks like this. And you have h of x that looks like this. Okay. Now, how would we set up this integral right here, a? So the question now asks you, can you find the top function and the bottom function? Okay. Can you now find the top function and the bottom function? For this particular case, it's not immediately obvious because there are places where, well, h is always on top. Okay. So focus on a. So we focus on this area right here. Okay. That's the area that we're focusing on, right? So h is always on top, but there are cases where g is below, and there are also cases where h is below, f is below, right? So let's just figure out where it changes. So what we can do is notice that at this point right here, at x equals 1, right? Notice that for this area right here, what do we have? So from here to here, h is on top, and what function is immediately at the bottom? It would be g. Okay. Then from this to here, okay, from 1 to 5, what do we have? H is still on top, but what is now at the bottom? Notice it's F. F is now at the bottom. F is below. So how then do we find the area A? So we use this, right? So from -2, notice, from -2 to 1, H is on top. So that would be the top function, minus G is below, minus G of x dx. Okay, so this gives us this area right here, the one on the with the vertical stripes, plus the area of the horizontal stripes. So it would be from 1 to 5 of the top function, it's still h of x minus f of x dx. This is now the final answer. Again, you don't need to find the value because again the question is just telling you to set up the integrals. All right. So yeah. So for today, for the first video, what we did is we just discussed what the uh uh what area under the curve means. So this is a tangible application of the fundamental theorem of calculus that we discussed last meeting. There will be a quiz that you can do at any time that you want. This will be graded and will be part of your seat work. Okay. See you in the next video. Bye, guys.